All right. On Wednesday, we talked about reference angles. You already have this written down. There is no need for you to write it down again. But let us recall, because it's been a couple of days now, what reference angles are. Okay? Reference angles are the positive acute angles that measure from our terminal side back to the, which axis? X-axis. Okay? Notice how I did say positive. They always need to be positive acute angles. All right, so let's just draw our pictures to refresh our memory. If you have an angle in the first quadrant, the reference angle is itself. Okay? In the second quadrant, the reference angle would be its supplement. In the third quadrant, the reference angle would be however much past 180 or pi our angle is. And then in the fourth quadrant, we're talking about how far away we are from 360 or 2 pi. Okay, now on Wednesday we worked with all of our unit circle values. Today we're working with values that are not special on the unit circle. Okay, we still have values everywhere on our unit circle. We're just memorizing the special ones, the ones that have the special relationships with the special right triangles. Okay, there are an infinite number of points on the unit circle, but only the 16 that I gave you are the ones that are worth our time to remember. All right. So let's first of all practice finding reference angles. Go ahead and graph the angle 325 degrees. Eli, which quadrant?
4.
Okay. And how would we calculate the reference angle?
360.
Which would be how many degrees? So our reference angle is 35 degrees. Okay. What we can do with that is, like if we can calculate the tangent of 35 degrees, then we know that the tangent of 325 degrees is that same number, but negative since we're in the fourth quadrant. Okay, same kinds of things that we can do on the unit circle, but just not with the special values. Okay. Next one, 7 pi over 5. Let's see if we can graph this one. Which quadrant would 7 pi over 5 be in, Chris? The third? Okay. Pi we can think of as like 5 pi over 5, right? 2 pi, 10 pi over 5. So 7 pi over 5 is going to be in the third quadrant, but probably closer to that 3 pi over 2 mark. Okay, so there's our angle. We need the reference angle. Okay, Lindsay, how are we going to find that? What's our calculation?
7 pi over 5 minus 5 pi.
Okay, so 7 pi over 5 minus pi. You went ahead and changed it to 5 pi over 5. I like it. So 2 pi over 5 would be our reference. got a strange one for you. You ready? Any questions about the 2 pi over 5? $2.3. First question you need to ask yourself, is this in degrees or radians? This is in radians, isn't it? There's no degree symbol. I don't care if there's a pi with it or not. Since there's no degree symbol, we are in radians. Okay? Now we typically don't think in terms of decimals, right? Okay. Well, we know that this is pi over 2 radians, and this is pi radians. Where does 2.3 fall? Let me ask you this. Pi is approximately 3.14. And so half of pi would be half of 3.14, which is like what? It's like 1.57 or something like that. Okay. So 2.3 would be in which quadrant? Second. Feels awkward, doesn't it? Okay. So our reference angle needs to take us to the x-axis. All right. So Callie, what would the calculation be that we need to make here? Okay, so since it's pi, we're going to use 3.14. I like that you already had put it in a decimal for us. 3.14 minus 2.3 would give us there's our reference. All right, let's talk about when we have a coordinate. Okay. I have a picture drawn for you here. Oh, before we do that, sorry, I forgot about the slide. Okay, I just want us to recall again, all students take calculus. If we're talking about our 3 major trig functions, they are all positive in the first. Only sine is positive in the second. Only tangent is positive in the third. And only cosine is positive in the fourth. Okay, obviously the reciprocal functions will be related to those 3 major trig functions. But of the 3, the ASTC can help you remember who was positive in which quadrant. Okay? I'm asking you to evaluate the six trig functions of our angle if the coordinate -3, -2 is on our angle. Okay, so at least draw our angle with coordinate 3, 2. -3, -2, sorry. Now, what is the point of reference angles? The point of reference angles is so that we can draw a triangle using the terminal side and use the reference angle to calculate the 6 trig functions. Okay? If we can draw a reference triangle, right, we have to have acute angles in a right triangle. Okay? If we use that reference angle, which is an acute angle, to draw a triangle, we can set up ratios for sine, cosine, tangent, etc. All right? So, since we're in the third quadrant, okay, this right here is going to be our reference angle. We can draw, oh, that is terrible. We can draw a reference triangle here. Okay, now, how far over did we go? 3. And how far down did we travel? 2, because our coordinate is 3, 2. Yes.
I thought that the radius was always 1. So, like, how can that be 3?
So we are no longer working on the unit circle.
Oh.
Okay? We're no longer working on the unit circle, so we could have coordinates anywhere. All right? Now, if we are on the unit circle, then we would know that cosine is -3 and sine is -2. But when we move off of the unit circle, we have to calculate everything from scratch.
Okay.
Okay? So if we have a side length of 3 and a side length of 2, what would our hypotenuse be? Radical 13. Okay. 3 squared plus 4, 3 squared plus 2 squared would be 13. Okay. So now we can set up our trig ratios. And I'm going to tell you we can do this one of two ways. Okay. You can either say, all right, we are in the third quadrant, so I know that sine and cosine are negative. Tangent is positive. All right? Our sine ratio is 2 over radical 13. And then we rationalize it. Our cosine ratio is 3 over radical 13. And then we rationalize it. Our tangent ratio would be 2 over 3. Okay? That is option number 1. Option number 2, if you feel that you are going to forget to put in your negatives, you can label this side as -3 and this side as -2, so that when you find your ratios, the negatives are accounted for. Okay? Obviously, we don't have side lengths of -3 and -2, but you can account for moving left and moving down by labeling them that way. That way, when you take your sine ratio, you have a negative value. Your cosine ratio, you have a negative value. Your tangent ratio, it becomes positive. Okay. Okay. Don't forget that if you have already rationalized a sine, cosine, or tangent ratio, do not flip it and rationalize it again. That is more work than you need to do. And especially when you're like, you don't want to be working with 13 and then reducing, okay? Cosecant, instead of going to sine, go to your triangle. Cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And then the cotangent would be 3 over 2. Okay, I'm going to show our next example. What I want you to do is write down the information that you want to. You don't have to write down every word, but you need to write a little bit down. And then I want you to draw a picture representing what I have up here. Okay? Let -3, 4 be a point on the terminal side of theta. Find sine, cosine, tangent of theta. You need to have your XY axis drawn. You need to plot the point -3, +4. So we are in the second quadrant. Okay. Now theta could be a number of different angles, right? There's an infinite number of angles that are coterminal to the one I have drawn here. So this is probably the easiest for us to think about, right? So we are going to draw a reference triangle here. Okay. We move to the left 3, we move up 4, and this is nice. What is our hypotenuse? 5. So like I said, you can do one of two things. You can either say, okay, I'm in the second quadrant, sine is positive, cosine tangent will be negative, or you can label negative side lengths on your reference triangle if you want to. Okay, that's not going to bother me. All right. So Nick, what's our sine ratio? Okay. Chad, what's our cosine ratio?
Wouldn't be 3 on 5.
Okay. And is it Grace W? Right? Okay. Try to get last name figured out. What would our tangent ratio be? Yeah. 4/5? How do we find tangent?
Opposite over adjacent.
There we go. So 4/3. There it is. Okay. Those two problems are pretty similar. Okay. You need to be able to obviously get to there. Now, I'm going to give you a different set of information for us to be able to figure out, once again, the 6 trig functions. All right? Go ahead and write this down. The tangent of theta is negative 5/4, and the cosine of theta is greater than 0. Find the other 5 trigonometric functions. Why is it necessary for them to point out that the cosine is positive? And as opposed to, okay, so Maverick's saying we know that it's in the fourth quadrant.
Wait. It could. Oh no, it's in
So it could be in the,
wait, else?
right, so if we only had tangent as negative 5/4, I mean, you went like straight to like what I was gonna ask next.
Oh.
Okay, you are thinking correctly. But if we only had tangent as negative 5/4, it could be in the fourth or the second, okay? But same, so tangent is negative in the fourth and the second. But saying that cosine is positive, well, only the fourth quadrant is cosine negative and tangent, excuse me, cosine positive and tangent negative. Okay, so by giving us that the cosine is positive, we can narrow it down to the fourth quadrant. So our reference triangle needs to be drawn in the fourth quadrant. You have to draw your reference triangle in the quadrant given to you. Okay? If the tangent is 5/4, then opposite over adjacent needs to be 5/4. I would split it up to where you have just integer values there. Okay. Please find me my hypotenuse. Oh, somebody already had it. What? Marissa has radical 41. Do you agree? Radical 41 cannot be reduced, but if it could, you would need to do that. Okay, so here is a situation where maybe labeling the sides as positive or negative could be helpful. Okay, I know that you guys can draw a triangle, label the tangent as 4/5, find method, hypotenuse, radical 41, and you can identify the trig functions based off of that triangle. However, if you don't consider that we're in the fourth quadrant, you're not going to get the negative and the positive. Well, you're going to get all positives, and you're not going to label your negative ratios. Okay? Okay, so either you say, okay, I'm in the fourth quadrant, sine and tangent are negative, or if you'd like to label it on your triangle, which side would be negative? The 5, because we have to travel down, which is in the negative direction on our coordinate plane. Okay, so our sine ratio is 5/radical 41. Our cosine ratio is 4/radical 41. And our tangent ratio, we already know is negative 5/4, but we can write it again anyway. Okay? Which means our cotangent is negative 4/5. Our cosine, radical 41/4, and our secant, reciprocal of cosine. And then our cosecant, the reciprocal of sine, would be negative radical 41/5. So let's talk about what you need to do this weekend. First of all, I won't see you till when? Tuesday. You have a 3-day weekend. Okay? You have a book assignment. Obviously, you need to do the book assignment. With the snow day, I've decided to give you your problem set still today, due on Tuesday, okay? But since you might have questions on your book work, you might have questions on your problem set, I'll collect the problem set at the end of the hour as opposed to the beginning, which is what I usually do, okay? I want to give you a little bit of information about the problem set.